Waymay Delgado is a continuing lecturer here at Purdue in charge of Applied Calculus 1, which enrolls more than 1,000 students each semester. Ben Wiles is now Chief Data Officer at Clemson, but when he was at Purdue, he was the instructor who transformed the Plane Analytic Geometry and Calculus 1 course. Ben and Waymay will talk with us today about lessons they've learned transforming these courses through the IMPACT program.
All right, we've got all the die-hard educational transformers left. I like it. And we will be talking about motivation, active learning, and calculus. So for the first part of the presentation, I'll be preaching to the choir. And the second part, Waymay is going to come over here and beat a dead horse on that. But we did want to share our perspectives on doing this and sort of maybe the long arc and address some of the things that we haven't talked about so far in this. And so we'll go through some data, some history, and one of the first things I wanted to point out is that when we talk about these things, it's very clear that they're not new ideas, right? So you talk to anyone, an old timer in a math department or any department, and they've been working on these things forever. And so at Purdue, even in the 1950s, the course I'm talking about here, which is the Calc 1 for engineering, we had a TV-taught version of that course. And they had an experiment where they bought a color TV, actually a 25-inch RCA, and they put a bunch of students in front of it, and I imagined them in skinny black ties, and to see what the effect of that was relative to having a real-life mathematician in charge. In the 60s, when they were expanding the department and changing some of the roles over from people who really taught 4-4 and trying to become what we all know now as the modern research university, they needed to reduce teaching load. And then to do that, they created the lecture recitation format. Same thing, they did some experiments and basically saw that it did no harm. It also let them decrease teaching load. And so it got widely adopted, and that's the format that continues today. So when I say traditional, it was developed right there in the early 60s. In the 70s, we even had some more interesting things. This is in differential equations, not in calculus per se, but the sort of next things in the sequence. It was a self-paced, competency-based version. And so there was a mathematician in the department who took it on her own accord in the summer to write alternate forms of all these exams and things. And they would come to a help room, and there would be a secretary there figuring out where they're at. And they would take exams, and she would grade them and give them the next problem set and so on. And the results for the first 2 years were very, very encouraging. And I wanted to address sustainability in that. So why not? It sounds great. These are all the same things we would think about today would be a good idea. Well, so she was sort of martyring herself to do this. There was no summer pay. She cared passionately about it and engaging with the students. In fact, if you want to read more about it, the little notebook that the secretaries would keep is still over in the archives, and you can finger through it and see how the students were in there and stuff. There are social security numbers still in there that aren't redacted, so I don't know about the legalities, but I didn't tell the library staff. But, you know, they needed to scale and sustain that. So how do you do that? Well, you get other people involved and so on. Well, they didn't have the passion for it. It wasn't there. And so as soon as other people started getting involved, the performance tanked. So at first it was very high performing. They tried to scale a bit. No one was really there. And it was miserable for the people who weren't passionate about it. In fact, a man named Alan Weitzman retired a number of years ago. And he was the only person I talked to that remembered it. And his face when I mentioned it just like dropped. You know, he was like, please don't bring that back. And Alan is a wonderful teacher, too. So, I mean, he would be interested in such things. In the 1980s, there were some conversations about how engineering and the math department would engage in these calculus courses for engineers. And so I wish George was here, this idea of integrative learning. They took the exact opposite approach. And basically, engineering wanted to be able to teach mathematics over there. And they said, well, you can't really teach the applications like we can, and so on. This has been a battle for a long time. And so the agreement that they came upon was to create two sequences, and the math version would be entirely devoid of application, and the engineering version would be entirely devoid of mathematics, and they would be taught, but they would collaborate behind the scenes so carefully over the years that it would be perfect for students. Of course, that all fell apart, and so it's 181 and 182 for people in the room who might know. They became the honors version of calculus, and of course, those engineering courses then did what they would. In the 90s, we were talking about this earlier, a version of Engineering Calc 1 still exists where it has one recitation per week instead of two, otherwise it's still large lecture, and it was created for reasons that aren't terribly interesting due to recommendations from ABET in the 90s. But we did have a version that was meant to be more streamlined, more engaging, and the difference besides having one recitation versus two is that they had collaborative quizzes in the recitations. They worked together. They still do this today, as far as I know. The man who championed that and shepherded it all the years is no longer with the department, but has been kind of adopted by another mathematician in the department who takes care of that. So again, similar ideas. In the 2000s, supplemental instruction kind of came back in more force. We started to think about placement strategies again. These things had been considered for a while. Anyway, that gets us to today, and that's just at Purdue University, right? And so impact calculus, both of us are here representing two versions of Calc 1, and the learning outcomes we'll talk about in a minute, maybe the differences between the courses. And for my part, we were talking about origin stories the other day. Basically, the provost office identified engineering Calc 1 as a high DFW rate, high importance class, and approached the department head, at the time it was Laszlo Lempert, and who approached the associate head, it was Antonio Sabaretto, about the possibility of doing this. They came to me and said, would you be willing to do this? And I said, yes. And that was it. And so they basically left it to me to do whatever I wanted, which was super cool for me. They just wanted a thing. And then working with everybody in the staff, what would actually make this right? The first thing, though, I like to point out is that the first instinct I had, I'm a programmer, and I had worked in modeling and simulation in the automotive industry for a number of years before I got into other things. And so I'm a big fan of MATLAB and have a lot of professional experience dealing with that, and a lot of the applications from the course are all tied in. Of course, in engineering 106, it's not 106 anymore. Whatever it is now, they take 131. They use MATLAB too. I'm like, well, I'll make a MATLAB-based version of Calc 1 and it'll be amazing. And I looked up and I had inherited my office from someone who had been there for 40 years. There was a book on the shelf and it said, Calculus in Fortran, and it was covered in dust. And I'm like, oh no, I'm going to be Calculus in Fortran guy, and no one's ever going to be able to do this. And so, as long as I was there, we probably would have had a lot of fun with Calculus in MATLAB. It would have been great, but it was not what we did. It wouldn't be able to be adopted by other people. It takes so much work to make it sustainable. So if you're curious about what the learning outcomes look like, I use the word mainstream calculus here because that's what the Mathematical Association of America calls this. It's the calculus courses that lead into other courses. So if you're going to take differential equations, if you're an engineer, you take what we call mainstream calculus. There's business calc. There's all these other things. But it's very common, the way they're structured, the content they cover, and it's AP calculus, too. It's just about that. So I'm not going to go through these, but I will we may give a shot. Do you want this?
So the other calculus sequence that we have is 16010 and 160 microphone.
Not right.
Okay, thank you. So the other sequence that we have is 16010 and 16020 for Calc 2. Not confusing at all. The other course is 16100. This is 16010. Totally not confusing. Yeah. So this one has 3 credit hours versus the other one has 5 credit hours. This one's for business, health, pharmacy, technology, and many other majors. The other one was for math, engineering majors. So the differences of 16010 from 16100, we do not cover some topics. For example, we do not cover the inverse trig functions, hyperbolic functions, or log functions with other bases other than E. A few other topics. And then we also have fewer multi-step problems. But for the most part, they are very, very similar. And it used to be, actually, there used to be 3 sequences of applied calculus courses. We had a sequence for management, we had a sequence for technology, and we had a sequence for biological sciences. And then at the time when we did the impact, when I was in the FLC, that's when we consolidated everything. We combined into one sequence. So now we have one sequence of applied Calc 1 and 2. Yeah.
Right, so we wanted to talk about this, and so I said this idea that we could do anything we wanted. Of course, that's not true. there's a lot of things that have to happen. And one of the first things I did is I went to the curricular committee who oversees engineering calculus up through differential equations. And so Laszlo and Antonio and I all went to kind of present that we were going to do this and get their blessing. And one of the things they told us was that we had to use the same style of exams, the same assessments. And it makes a lot of sense, and it sets up an awesome quasi-experimental study that we'll talk about in a second. But it's also not what one would do if they were trying to transform the way they teach calculus. And so in some ways, it presents a sort of inconsistency in that, but nonetheless, that's what we did. The other objectives / constraints, we wanted to create something that was defined by student engagement, instead of defined by the things that we were doing. And we, of course, took that lead from CIE and all the things that had been going through Impact. Do you want to speak to some of those?
Yeah, so for the grading policy, we used to have a curve behind the scene at the end of the semester. So going through the impact program with all the changes that we made, one of the changes was to make the grading policy more transparent to students for our course. So we have a predetermined scale, but it's not a 90, 80, 70 kind of scale. We have some kind of curve in it, but it's transparent to students at the beginning of the semester. It's in the syllabus, so they can see exactly where they are. Create a more student-centered learning environment with more student engagement and collaboration. And we have been talking about this for 2 days, right? It's really important for students, especially for math class. And we often see in a classroom, you can listen to the lecture and copy it down. Okay, yeah, that kind of makes sense. Yeah, I can see that. But when it gets time to do the homework, you get stuck. Why is this way? Why is my calculation not right? And this and that. So it makes a lot of sense for students to do the note-taking and do the video watching outside of the classroom and come into the classroom to ask questions, to get stuck and ask questions and get help. So,
Yeah, I guess the only other one we should mention is, maybe it's obvious, that both of these courses are very large. In fact, I think Huime's course now has upwards of 2,000 in the fall semester. Between the two kind of versions of engineering calc, there's also 2,400 students. And so there's an economics of that in terms of space, availability of instructors. There's also this accounting of teaching load that had to be preserved. And we had to craft a way that made sense and, again, was sustainable in the department. You couldn't just one person teaching 500 students in a lecture hall and this faculty member gets to teach 15 in a collaborative environment. It doesn't work, it doesn't scale, it would cause problems. And so that was another thing sort of behind the scenes to take out, but it, again, speaks to sustainability.
So for the size, so now for 16010, we have about 2,000 students in the fall, and then this semester, spring, we have 850. So that's the size. The structure of the course, so I can choose to teach a few sessions of small sessions or a larger session of 120. The other sessions are all taught by graduate teaching assistants or limited term lecturers in sessions of 40. So going from the traditional to the impact, I teach the same number of students, but just in the impact environment. But I'm the only one teaching the impact sessions. We haven't really explored having the graduate teaching assistants to lead their independent impact sessions. That would take quite a bit of training and to be consistent across the board. So we haven't done that.
Right, and I referenced this earlier, and so one of the things I wanted to point out, if you follow the calculus reform scene, there's a lot of talk about calculus reform that started in the 80s, and it started sort of, well, at least coincided with these sort of math wars arguments. But recently, the MAA realized that we didn't know much about who was taking calculus, what were they doing in the classroom, how were they doing, et cetera. And so they launched a 5-year study of this, and they came out with recommendations of highly successful calculus programs, or however it's phrased. And I only put this up there to point out that it's all the right things. So this wasn't public at the time we started or the time the impact came, but at least that there's cohesion within math education and mathematicians in the things we should be doing in the classroom. One of my favorite findings from the survey they gave of departments was that they all thought active learning was, not all, a large number of them thought active learning was a powerful tool for learning. They also reported that almost none of them did it. They reported that they would like to do it, and they reported that they didn't know how to do it or how to measure whether they were doing a good job or not. So there's a gap there, right, that speaks to why we're here, and I think some of the things that we can learn from our project.
Yeah.
So this just talks about what was done. So we flipped calculus. There's nothing terribly interesting about what we did. We came up with a model that worked for us in our department. So the normal version, you have 500 students in a large lecture hall, recitations that are led by the TAs, and you just kind of plug along. You don't even make the calendar for the course or the homework when you're teaching this, even the faculty who are teaching this. You just kind of go, and it's fine for what it is. I didn't realize at the time, and I was told by others in our department, how much of a change this was. I mean, so the other version, the problem-based version, has 0 lecture. There's none, no lecture. They just do problems. And so the associate head, now, after we talked to the calc committee, he had kind of sworn off, I think like 20 years ago, teaching calculus at all because he hated the way it was taught. And he wasn't even on the calc committee, he wasn't even the people who taught it, but a colleague of his was, and he mentioned, so Jim McClure is his name, what we were doing, and he came to my office and said he wanted in, to do this and to do it right. And so he was instrumental. If there's one person who was instrumental in making this sustainable, he developed these rich problem sets that he had probably been thinking about for 25 years, and it was a way of deploying them. So there are these rich problems that were carefully crafted. He would come up with a set of them. We'd sort of socialize them with TAs and with me and some other people in the department and tune them in, and that's the crux of the whole course. In the original plan, well, it's what we did. I had a small army of TAs at my disposal to do stuff, and I had them we had boiler casted lecture caught, or whatever you want to call it, various calc courses, and I had them chop them up into bits and tag them and put them into a library of topics that was searchable within Blackboard, and I thought this was awesome. They're going to just love this. Well, turns out nobody really, you can check who watched those. That's not what they did. And so it was interesting to me, and I'll talk to that more later, about like how the students are learning and, the things that we think could be awesome, it's not how they're learning. And honestly, so the national average is 75% of students in mainstream Calc 1 have already had the course in high school. And at Purdue, it's 99%, just from talking to students. But that's it. So we flipped, we had a problem session, and then we had 2 collaborative things that were still taught by TAs. In the original version, we had them present to the whole class, and we videotaped the presentations, and we put them in Blackboard so they could critique each other. Turns out that's really stressful for students who may not feel like they're doing really well, and so we had to ratchet that back over time. So they presented to their TAs in small groups about what they were doing and said it wasn't recorded, et cetera. So these kind of tweaks along the line were super important. In the original plan, too, we had an undergrad TA. We sourced them from supplemental instruction to provide cohesion across that environment. Turned out that they weren't quite the mathematical level to understand the depth of the problem sets and the careful points in that, and so instead we sourced math majors to do it and aligned it with the rest of our hiring of undergraduate math majors. But that meant they had to be trained in other things that the SI leaders came kind of pre-packaged with. So another minor adjustment, but any of that could vary across institutions about how to deploy such things.
So for the applied Calc 1 course, we don't have recitations even for the traditional sessions because we have 3 credit hours instead of 5 credit hours. So traditionally, we have 3 50-minute lectures on Mondays, Wednesdays, and Fridays. So with the flipped version, we only have 2 50-minute, I call it interactive sessions, classes. So we omit 1 50-minute class time. So students are supposed to use the 50 minutes outside of the classroom to preview the material, to do the pre-work before coming to class. So in the classroom, we do, I give them a worksheet to work on. So for the class, students just work on the worksheet, and when it's necessary, I come in and address some issues. And at the end of the class, I might get everyone together to just go over the worksheet briefly, highlight some difficult points, or highlight some common mistakes. I would say altogether, I probably talk about, for about 15 minutes out of 50 in front of everyone together as a group. As far as the grades go, the only difference is the quizzes turn into worksheets that we do for the impact class. In the traditional class, they give quizzes, and those points are allocated to worksheet points for the impact class. Everything else is the same. They take the same exams.
And in terms of just change management, again, and sustainability, I'm a firm believer in that if you build a highway, people will drive on it, right? And it'll be hard then to change their behavior after that. And so this is the organizational structure by which Calc 1 is offered. And it was a real, and I think even to this day, a little bit of a challenge between people in CIE to understand how much of that do they need to understand to support the faculty, to support the TAs doing that. And for it to sort of run naturally within the department. And so it takes a village, and you've got to get all those people on board and find out how far you can push them and be able to fill the gaps. And fortunately, when you have large institutional endeavors, there's a lot of places to fill the gaps. What are the needs of the department to make these things happen? Anyway, so Hui-Mei spoke to this about, the TAs possibly, is there a possibility that they could teach the impact version of 16010? The answer is yes, but you'd need to really work with the Director of Graduate Teaching who hires and trains these TAs. We have 200 and some that teach for us, and it's not easy, right? And when things go bad, they go bad, right? So he keeps things not going bad, and that's like his full-time job. So it's something that could be done in a phase 2, phase 3, but in a phase 1, probably not a good idea for us.
So we do have, Dominic, that trains all the graduate TAs just for regular teaching. So if we are going to scale this up to have the graduate TAs hold their independent impact sessions, some kind of training will have to be done. So Ben did this slide for the rotating course coordinator because for 161, we have rotating course coordinators. For 16010, for my Calc 1 course, we have a fixed coordinator, and that's me. As long as they ask me to do it. So actually for a few courses, for our algebra, pre-calc, and then this calculus 1 and calculus 2, we have a fixed coordinator over semesters. So there's a lot of consistency there, and it's also, it makes it easier to implement any changes and to sustain the changes. So I forgot to mention in the earlier slide with the impact style, the impact transformation, with the 2 lessons instead of 3 lessons, also in the classroom, I do typically have 2 graduate students and 1 undergrad helping me inside the classroom. In the classroom, I have tried different sizes. I have tried sizes of 40 and 99. There was a classroom, the capacity was 99. And then 60, and I've been liking the 60 more. I've tried all these 3 sizes. I've been doing 60 more often. So in the classroom, all the helpers will go around and answer students' questions.
So Jim and I co-taught the pilot of 161 Impact in spring of 2014. And then after that, I think Jim's taught maybe once or twice since then, it was actually handed off. People knew what they were getting themselves into, and they would go observe a class and see what it looks like, but they didn't have formal training. It was word of mouth, and people self-selected into teaching that. And in 2015, it joined the STEAM program, where we actually started taking lots more data. We gave the calculus concept inventory, a short form of it, pre-post as per the sort of experimental design in general. And we gave them the same motivational inventories that have been talked about here, framed in self-determination theory, et cetera. So what I wanted to show here, this is just I think this is the first 2 years of data, and I recalled when I brought this is actually, so we did the same thing in 162. There's the same idea, So this is the first 2 years of that, so 4 semesters of outcomes from that. So everything up here is statistically significant except for the things that are very close together, and we'll talk about those. But I wanted to point out, this idea that we don't know how to evaluate active learning implementations. Maybe we don't even know how to do it, but if you can't evaluate, then you don't know how to do it. There's no R&D process. And so, what I'm arguing is that this provides us a way of navigating that. So what would you do otherwise? I mean, so informally, the students in the problem sessions were amazing. They worked bell to bell. We don't have bells, but they talked about math. They were doing math the whole time. I had never seen that much engagement in my life. They might have been doing that somewhere else, but it was great. The TAs, when you talk to them, their sessions went amazing. So there's the things about the presentations and freaking students out for a while, so we got rid of that and massaged things as needed. But, so what else would you look at? DFW rates, it's a very reasonable thing to look at, I suppose, and try to make those mesh with your experiences. Teaching evals could be a thing to look at too. But how do you know who it's working for and why it's working for them? And that's why, as a math teacher, I value so much the motivational framework, that is hopefully how we know why these things are successful and for whom, which is why I split out the demographic groups here too. So we have a large number of international undergraduate students at Purdue and the College of Science and Engineering even more. So about 27% of the students in there were international. They have a very different academic and demographic and cultural and social profile, and I can talk about that, but I took them out of the population here so that I could include Pell and URM, those attributes don't apply to international students. So the top line is all the domestic students, so the numbers represent the number in the control versus the experimental version. And you can see just the pass rate, so 7 percentage point increase in the pass rate in the course. That's phenomenal. That's over 4 semesters, a large number of students, and that's not me or Jim teaching. That's other folks. So we think that's great, and there's been some variation in that over time, and when we get all the data, we can look at what happened when. The average grade also increased, which makes sense. You get a better pass rate here for domestic students than a better increase in the pass rate for domestic students than international, because the average grade point average of an international student on that course is 3.0. And so when you think about a bell curve and where C lives, the pass line, so if you're moving the middle here, that's the mode sitting above the pass line, so you'll get much more of an effect. So they actually had the same increase in GPA, just not in the pass rate. And this is a really simplified version of motivation, but when I say motivation here, I mean the high-quality, internally regulated motivation that John Marshall can tell you all about, and Chantal spoke to with the big model yesterday, if you saw that. Same ideas, same measurements, same tools, and that we saw all the appropriate, this is a very sort of naive analysis of that, just looking at the simple correlations, but it was exactly the right direction. It agreed with everything that we expected. Similarly, I pulled out women. Thought maybe our social dynamics in the course might not work for them. Women who take calculus are also much more often in biology or biological sciences and in teaching. Men are more often in science and engineering, and that's a national trend. It's certainly true here. But we saw the same, everything worked the same, so that's great. Similarly, at the bottom line, Pell, we saw a tremendous increase in pass rates. Everything worked great. Everything was there, and you've probably already noticed, for our URM students, and URM is just it's an attribute in the student information system aligned with IPEDS definitions and so on, so it has all sorts of problems. It's a big lump. That's probably the most interesting thing here, and the thing that needs a deep dive with probably people who are more aware of social and cultural and motivational factors than I am. Everything looked, well, one, you see there's no difference in the pass rate and no difference in the average grade. The motivational correlates in the lecture looked like everybody else. And the internally regulated motivational measures in the collaborative section was negatively correlated. And that's horribly astonishing. I mean, it's interesting, right? But without this kind of information, you would never know who was being helped and why and so on, right? So there's things that need to be dug into here. And that in and of itself is something worth pursuing in detail. And I'm sure a lot of people in here have theories about why that would be. And I've spoken to people about it too. Anyway, so the only point I want to make is that you wouldn't get this lens on this data in this context without doing something like this.
So we'll take a look at some qualitative feedbacks from students. So this is the teacher evaluations for my sessions last semester for both of my impact sessions. So positive feedbacks at the top, some suggestions, comments, negative. Suggestions at the bottom. I really like the reverse classroom style because I could take notes at my own pace and then easily get help while doing a worksheet or homework in class time. That's exactly what we wanted to happen. So that happened for that student. I appreciate that the in-class worksheets that allowed us to work alongside other students in our class. So yesterday, the presenters also talked about the value of working with peers. So that's also there. The course had a very well set up in the classroom. The TAs were very helpful to answer questions in a timely manner. And again, the prompt feedback, that's a very important part. And that's there. Really down to earth, talking about me, really down to earth and socialized with the students. She made sure to visit every student she could and explain the concept of the lesson in great detail. So about the relatedness, and I'm a firm believer of the relatedness and creating an autonomy, supportive environment for students. And I make sure I walk around and interact with every student, not in each class, but over a few classes. If I work, if I talk to these students this time, next time I make sure I talk to the other students. I have talked to every student in the classroom this semester. I find that just by asking simple things, they really make connections with you. Or if I just make a comment, that, oh, I really like your laptop cover, it's really cool. And all of a sudden, they just feel closer to you. And if they say, oh, I have to take an alternate exam next week because I have to go to a competition. And I say, oh, what competition are you going to? And things like that can just be some very simple conversations. And they can all of a sudden feel much closer to you, can relate to you. And then we can dig into the math. And I also like to compliment them, which I don't get to do in a traditional classroom setting. You don't get the opportunity to. You just present, you just teach. So when I walk around, even if they are stuck, but they have a good first step, and I would say, well, your first step is great. Now let's think about how to do the next step, or let's see what's wrong here. But I often try to find whatever I can praise about them and praise them. And they really like that too. Well, let's move on to the next, the other comments and suggestions. Since I'm in the impact course, I had to do a lot of stuff on my own. That's a common complaint, right? They don't see the reduction in the classroom time, like the 15 minutes that we're not meeting, as their responsibility to do work outside of the classroom. So when they have to do the preview for the class, they feel that's extra stuff to do. So that's a common complaint. So I make sure that at the beginning of the semester, I communicate them over and over again how the impact works. What does the flipped classroom mean? Next one, a suggestion is to teach some of the lesson in class so there is more clarity for students who have trouble with the material. And the next one is similar, to include small lectures on the subject before the worksheet. So there's always a part of them that wants the lecture being given to them. There's always that part there. So again, I reiterate how the impact classroom, how the flipped classroom works. And for that comment, I usually do get everyone together to talk together for 10 to 15 minutes to make sure that everyone has a basic understanding, has a big picture, so especially for students that are less prepared, or even if they don't do the pre-work as they are supposed to. I don't want to just, leave them hanging to dry. Because, if they come in, they're not prepared, but I still want to give them a little bit. So I do lecture some or talk some, present some, but just given the constraints, given what the flipped classroom is, I just can't do what the traditional classroom does. So there's always a part of that they want the lecture to be given to them. So I will also encourage them to come to office hours, which I have a lot. Have review sessions, a class before an exam, instead of learning new material. So that's a challenge because how we cut down the 15 minutes, we don't have another class. The students still rely heavily on, like, we have a class and that's a class. If we don't have a class, I don't have responsibility. So if you think of the cutoff class as their review class, it doesn't work as well. They don't think of it that way, right? When I designed the calendar for, let's say, for the traditional class, they have a review class on Friday. But for us, we don't have class on Friday. So that's supposed to be their review class, but students don't perceive that way. That's where the comment comes from. So there are some challenges there about designing the calendar, how to fit the time. We'll talk more about it in the next slide, or 2 slides after.
Yeah, so then I think we just wanted to talk about our lessons learned, and whatever I was thinking at this time, these are the things I wrote down. And the first one here, I addressed it a little bit earlier, is technology won't solve everything. I think everyone knows that, but it might be good for you for logistical reasons, but what are the students really doing with it, and how much of it can you use in the classroom? So being mindful of that, I guess. Understand how students are being successful. So the fact of the matter is, in large lecture calculus, we didn't require attendance, we didn't monitor it, we didn't even particularly encourage it sometimes. It was up to them, do what you will, and come. And so some of our most highly rated lecturers actually had attendance less than 30, 40% in their classes as it drifted down. This is not uncommon. So day one, you get everybody there. And so they're learning somehow, right? We need to figure out what those things are, right? And I made this library of videos I thought was super cool. And they, didn't bite. They were doing something else than that. Number 3, you are wrong. So I think maybe we're all adults and we know that by now. I think what made me think of this was it was a TED Talk or something like this. So a woman who studies people feeling wrong. But she asked people, what does it feel like to be wrong? So I'm going to ask you, what does it feel like to be wrong? Embarrassing, intimidating, deflating. And so I'm going to tell you, you're all wrong. That, making her point, is that it doesn't feel any of those things to be wrong. It feels like that to find out you're wrong. To be wrong feels just like being right. Deep, 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 You're a Wile E. Coyote running off a cliff, until you look down. And I'm an educator, so if you ask me what I am, I'll say a math teacher, and so being here is a wonderful experience to be able to be involved in all of this. I know a lot more on average and have more experience in the classroom than most, but I was so wrong, and so maybe it leads me to the rest of these things. Include everyone and ask for help, especially at a university like this that has so many resources to offer. You wouldn't believe who's willing to help you and whose job it is to help you, and they want to be able to put things on their annual eval to affect students in the classroom. Yeah, this is a wonderful conduit to do that. What's the worst that could happen? I think relative to the lecture environment. I don't know if I should say this on camera, but I don't think we could have done any worse, right? They weren't really learning in lecture. What was the risk really associated with this? One of the risks was that the students would revolt, right? They would just see it as something that isn't part of what they would be doing. But we took a lot of efforts to make sure that didn't happen. One, we worked with the people who train the TAs and so on and thought about this. We held a focus group with some of the students before we got into this just to talk through it. One of the things that came out of that I like a lot is there's funding that comes with being an impact fellow, about $10,000 for doing the whole bit, and we did 2 courses. That's $20,000. So what do we do with that? Well, we're a big operation. What's the most impactful thing we could do with that money? Endow a cookie fund. And so I put the money into an account, and Mary Lou's delivers cookies every Tuesday morning, and then the 75-minute problem session, whoever's teaching it walks around and says, would you like a cookie? How's your math? And that turns out to help mathematicians a lot. And students like that too. At least it makes it feel like you're thinking about them and so on. So I hope there's money in the cookie fund still.
Well, we need to talk later.
Oh, no.
Let the driving get it now.
I see. Okay. So I've been corrected. Listen to the students and the TAs. We talk to the TAs. Feedback from the TAs is awesome. They know what is going on in a lot of ways that we don't. Measure, learn, and retool, and I think I've talked about that enough. So, Wei-Mei?
So some lessons learned from the implementation aspect. So this is actually the end of my 4th year teaching impact classes. So these are a few things that I learned over the last 4 years. First, expectations. I found that actually discovered that it's very important to communicate with students what the flipped classroom is and what are the expectations. And you cannot get the points across by just telling them once on the first day. And they don't exactly know what it is, how it works. So the first day I explained and I reiterate what a flipped classroom is. And I explicitly explain how the 50 minutes that we are not meeting, they are supposed to use that to do the pre-work. It's not that we just have less work to do, we have less class time. We have the same kind of workload as the traditional class. And then explain how the schedule align. If we only have classes on Mondays and Wednesdays, and the other sessions have classes on Mondays, Wednesdays, and Fridays, and then how homeworks are due, and all these details. And yeah, the first time, the first semester when I did it, I thought, okay, they'll just get it the first time I tell them. They'll just follow it exactly. Yeah, it wasn't that way. And so every semester I make that point many, many times. I find that usually by the end of the third week, they get settle into the routine. They know how things work about the end of the third week. And they also find out whether or not this is what that works for them. Emailing reminders. So because we have classes on Mondays and Wednesdays instead of Mondays, Wednesdays, and Fridays, so the homework due dates might be different from the other sessions, and then and also they are supposed to preview the material before coming into class, although those topics are on the calendar, but somehow a reminder helps in those situations. So there have been many times the students come to me and tell me, oh, thank you for always sending out those reminders, they really help. So I email them the reminder the day before class every time with what homework is due, what to preview for the next day. Worksheets, quizzes, and pre-work assessments. So I have tried different things. So when I first started the first semester, I had a pre-work assessment in every class, a quiz every week, so every other class, and a worksheet in every class. So the pre-work assessment was to make sure to motivate that they preview the material before coming to class. That's a big thing, right? How do we make sure they do their work before coming into class? So I gave them a pre-work assessment at the beginning of the class, something pretty simple, pretty basic. If you go through the topics, you will know. But it turned out that it didn't really work as well because the question is tricky to decide. If you decide on something too difficult, it will not be fair for students who have preview but just not able to understand it. If you have it too simple, they get it done in 2 minutes, and I also don't want the students that walk in late to miss the opportunity if they just walk in 3 minutes late and then they miss the opportunity. So I say, okay, you'll have 10 minutes. So if you finish the pre-work, I'll give you the worksheet. You can work on it independently. And then by the 10-minute mark, then we can all collaborate and talk. So for students who come in late, they still get to have an opportunity to do the assessment. But it turns out that they just cannot hold the questions and the desire to talk to themselves for 10 minutes. By the time they finish in 2 minutes and I give them the worksheet, by like 5-minute mark, they're like, hey, what did you do? They're talking. Then I will remind them, well, we are still, at 5-minute mark, we still need to wait for a little bit. You cannot stop them. I've tried many times, you just can't. So I gave up, that's not working. So I gave up that idea. And then also, with the pre-work, again, with the question, it's like, you can't give it too hard. It would not be fair, but you can't give it, if it's too easy, they get it anyways. Everyone gets it. So, and then about the whole, they cannot stop talking. That was a real problem in implementing that. So I stopped doing the pre-work assessment. I just leave it for themselves. The quizzes actually, when I first designed that, was always also a way to reinforce the to reinforce them learning in the classroom, I was afraid when I first started. I was like, what if they don't work in the classroom? What if they don't work on the worksheet, right? How do and I don't grade the worksheets. I just collected that worksheet. Oh, I didn't collect. In the beginning, I didn't collect the worksheets. I didn't want to grade the worksheets. But I wanted to make sure they were working on the worksheets. So how am I going to do that? So I gave quizzes. It was a question or two that were directly drawn from worksheets. Not change of any wording, number, anything. They were directly drawn from the worksheets. So I was thinking that students either had to work in the classroom. If they didn't quite understand it, they can review outside and they can study for it. I posted the worksheet solutions. So that's a way kind of to make sure they do go through the problems. So then I found out that, they didn't do any better than their regular quizzes, even though the questions were directly drawn from the worksheets. I gave them the solutions, and the numbers were exactly the same. And then also, the quiz would take away 10 minutes. 10 minutes is precious. Out of the 100 minutes that we are in the classroom for the week, 10 out of 100. It's a big deal. And then I was thinking again, well, for the 10 minutes they are taking the quiz, they are not learning anything new. It's an assessment to see what they learned and what they studied for, but they weren't learning anything new. We are not doing interactive learning. And I feel 10 minutes is a lot of time. So I wanted to switch that to turn the 10 minutes into more learning. So I got rid of that as well. So now I only have worksheets. So worksheets are the only thing that we work in the classroom. We just work on the problem. I still don't collect the worksheets. So now I do give points for the worksheets. Before I didn't. So the worksheets are graded by efforts. And basically, if they come to class, they get the full credit. But what I tell them is, you have to be actively working on the worksheet the whole time. It's not graded on completeness or correctness. It's graded by efforts, but you have to be here working on it the whole time. It's working out, I would say, quite well. And then engaging students in conversations. So I tell the graduate and undergraduate helpers, when you are in the impact classroom, you are always going to be talking. Even if a student is not asking you a question, you go there and say, how are you doing? Do you have any questions? So to engage them in conversations. And then calendar is about the timing issue that I mentioned earlier, since we're out of time, so I'll just stop there.
That's it.
Thank you.
We have time for a couple of questions. I'm coming, no, Dr. Noor, I'm coming.
Mike, if it's for me.
Oh, sure, sure.
Okay.
All right.
So in the impact course, you actually eliminated the lecture and use that as 2 hours for a lab or the worksheet, the interactive session. But the content that you remove from there, okay, it is still the other student, traditional student, or the control, they have it, right? Here you have 70 points for this session, for the interactive sessions. So does that mean that the students on the other side will get more points for the same content? And the second question is that these interactive sessions, are they reflected also on the exams? The question that whatever the worksheets, the content they cover during that session. So you 70 points for 1 lecture out of 3, correct? That's what you do. And then the second thing is that the content covered during these interactive sessions
Those
impact
are
session?
both
Okay,
wonderful questions. So Hume talked about the grading policies within 16010, and they went to a straight scale kind of format where all the points were accounted for, and she made that a wash in her course. You notice that in 161 we didn't, and it's because we were not able to change anything about the grading policy, and I'm not about to explain the math grading policy to the room. I've tried and failed for, I don't know, how long have I been teaching? 17 years here or something. But those points don't count. I don't want to say that exactly like that. They don't affect the final grade and the grade distribution. So there are more points. They don't affect, only the exams control the distribution within the sections. So that one is roughly even. But it speaks to the thing I talked about in the beginning about not being able to change the exams. So you're right. If we could have rewritten all the exams, we would have changed them, and we would have then changed the activities then to better align with those, still aligned with the content. We created activities that we thought would help the students learn and do well on the exams. The exams are written term by term by the group of lecturers who are assigned to teach at that time by committee. And so was there maybe some influence from whoever the impact person was? A bit, but at the end of the day, it's the coordinator who makes the exam accountable for it. So they were roughly the same, and we try not to be too creative on there. And the other thing at stake is the calculus concept inventory. It's also very different than the curriculum and the things they were assessed upon. And it's then hard when you step back and try to see who learned what, when, and how. But we can rely upon that the exams, I would say, before any of this, characteristically didn't change. You could have taken an exam from 2002 and given it to the students in 2017, and no one would have noticed.
Hi, Ben. Welcome back.
Hey.
I have a question. Tell us a little bit about the math culture, the math faculty culture, and the math instructional culture once you introduce this new teaching practice.
Can I plead the fifth on that one? No, I mean,
As much as you can.
no, so I'll go back to the 50s or whatever. I mean, so it has a long history of caring about education and people who have who care deeply about educating students. There was a mathematician named William Thurston who said it's the task of the mathematician to increase human understanding of mathematics. And that means a lot of things. That means discovering new mathematics, and that means increasing for the human population. I would say that no one in the department would disagree with that. So that's one thing that is important. But when we changed the department, I'm going to say we, in the 60s and 70s and 80s, teaching became a much less emphasized thing, and the people responsible for it were not the highly recruited faculty. And I would say whatever that means, and draw your own extrapolation, then that's probably more part of the culture. The new faculty that are hired in, I don't think teaching's on their radar at all. That being said, these people have been around for a long time. There is a curricular committee, and they have concerns about the students learning a lot, and maybe previously there was a notion of, I've heard people say, putting students through their paces is a good thing. That is mostly gone, as far as I can tell, at least the people teaching 100 and 200 level courses. So that's nice, and that was something that we would have had to deal with. Getting people to teach this, so one of the nice parts is that Jim became associate head a year after we did this, and so the associate head, together with the assistant head, who I was and Phil is now, sort of make the schedule go, and he was able to then recruit people who would be able to perform and wanted to. I would tell you that we also sent a survey, and we have for 50 years, to all the faculty asking them what they want to teach. And we more or less respect that. And not that many faculty request calculus at all. So there were a lot of things to navigate there, but I don't think there was I never felt any resistance. I never felt anyone was bad-mouthing the program. There are some people who maybe didn't understand what was going on or didn't necessarily care to change the way they were teaching. So be it. But there was enough people in the wings that it was going well, and you could ask Phil, he manages the requests now. Do people request impact? Is there a fight for it? And he's shaking his head no. So that's, yeah. And how much arm twisting is involved? Well, maybe the same amount as to teach calculus in the first place, maybe more. I don't know. Okay, so there you go.
Thank you. Chantel, do you want to come make some closing remarks, or should I bring the microphone to you?
Why don't we all stand up and stretch? Wow, that's been really a great 2 days. Yeah, I was serious. Yeah, stand up and stretch. Some people have, yeah, it's kind of like, okay. Well, you come to the end like this and you're supposed to summarize what happened. And you don't have to sit down. We can all stay standing up. But I want to start by thanking people who put a lot of effort into this conference. So Jenny, thank you very much. That was a lot of work. We did not put annual test conference, but we may have to put the name back. We had it, we took it out, we thought this is going to be a one-time thing. We may have started a new trend. So thank you. Thank you for everybody from CIE who really pitched in. Where are you at? Raise your hand. Yay, do the wave. All of our partners, I see still Craig out there from ORAE, librarians. Yeah. Anybody who's been an Impact Faculty Fellow? Where are you? Yeah, there's still some. Anybody who's been part of STEAM? People coming from Korea? Yay! Australia. A lot of people left for the airport, but I think we still have some of our presenters. They all had to go home. All right. I mean, that's okay. It's a long day, but thank you very much for being part of that. So I'm actually going to do something that John Marshall recommended that we do. What is it that you want to do, right? It's been a long day, but what I would like, or long 2 days, what I would like to do is instead of having, I have some notes of what I thought I could sort of extract as themes, but I want to see what did you extract as themes. So what do you have on your notes? So let's do a little minute paper. Close your eyes for a minute. Think about what are sort of the takeaway, and then tell me what you want to do, right? You could write it down and then say, we want to go home. And you could write it down and say, I really want to talk about this. Take a minute to be mindful and gather your thoughts. All right. Nathan, also thank you for doing all of the video and notes. We work very closely with their team. They're great. All right. So no pressure. Anybody would like to share? Or, yes, go ahead, Henry. I'm just going to, it's easy now. The room is.
Yeah, small room now.
Yes.
Well, as I look back on this, it's impressive to see all the work and things that people have done, ideas, methods, lots of great things. I was impressed with all the stuff in the literature that was out that I wasn't aware of, that I should have taken more effort to search for. But when I've been deep in the trenches, I forget to go look. And there's a lot of great things out there. There's still so much more to do. That's, I mean, that's why you have to do it again next year and broaden the circle. And there's still so much to share. I mean, it just gets better and better.
That's right. Thank you. Thank you. Absolutely. Yes.
So I guess like in the past, the 2 days, it has a lot of great information. So my takeaway is that we talk about the different strategies about the student-centered teaching to engage the students. So that echoes one of the article I actually read, and I wanted to share everybody is that teaching is not a hard work, but it's a hard work. Yeah.
It's not hard work, but it's hard work.
Yes. So we wanted to help the heart. Yeah. Hard work. Yeah, we wanted to make the faculty, willing and continue to develop and the teaching to help the students learning. Yeah.
That's when it would be good to have the catch box. You would have to be like, is it coming at me? It's somewhere, but it's back there. But one more? Okay.
That what stood out was the autonomy, the competence, and relatedness, and trying to incorporate that into teaching.
Absolutely. Not impact from the beginning has been based, well, not from the beginning, but from the very early beginning, very early time. It's been based in self-determination theory, and especially the work of John Marshall in education. And it's been wonderful to have you here to really talk about that. And the challenge when we've done the work is to strike the right balance when we talk about these basic psychological needs, to not be too theoretical, so we lose the application, but then not water it down, not to say that application, but retaining enough of it and working with you so that you apply it to your context. One question that you had this morning, Tim, was about, well, how do we do it? I think you asked a question, sort of, when is it okay? I mean, I'm flying planes and I can see that they're going to kill us and I need to do something, right? How do I do this in an autonomy supportive way? And I remember you asked something very similar when you were in the Impact FLC. And at the time, I kind of struggled with this. I thought, okay, I had John Marshall's answer, never good to be controlling. But then how do you do it? How? When you have to do it. So that's been really the challenge of this. So that's been very interesting. Dr. Nu, did you raise your hand? I can keep my microphone. I'm gonna do like a mindfulness check though here. So
Yeah.
do we still want to one more question
No,
then
I'm going to give it to you.
and we
I'm not
want to
going
go
give it.
home?
Yeah, one of the things that for me take home that it is really refreshing to see, to belong to a bigger tribe. Excuse me, I came from tribal setting. A tribe of professionals who are really seriously interested in student success and transformation of education. And also, you see actually your relatives in other institutions doing the same, or in other countries, they are trying to do that. And also, one of the strong message coming from a professional school that transformative education for student success is not a thing for undergraduate. It's actually a thing that can the graduate education benefit from it, can professional school benefit from it. So the question to me and my colleagues, how can we build bridges that actually capitalize on experiences from both sides of the aisle? Thank you.
Wonderful. Okay. Now we want to go home, right? Yes.
I will say that there is one way, speaking of tribe. I'm sorry, we forgot to talk about this earlier, Jenny. If you tweet, I have been tweeting from the conference using CIE's Twitter account, and we've been using the hashtag TESS_Purdue. So if you would like to keep that conversation going, we're going to keep watching that. So again, it's TESS_Purdue. Feel free to reach out to us via Twitter or CIE at Purdue.
Right. And just let us know some of the questions were like, what are the next steps? We may be too tired right now to think about next steps. I think we may need some reflection, but that would be is it a good venue to do this through the Twitter? Next steps? There you go. So, thank you so much. Have a wonderful weekend. It is Friday. Have a wonderful weekend.